So AI agents, yeah, I was quite excited to get into this paper. It's the first, I've not really had much exposure to this topic yet, and it's the thing everybody else is talking about. So I'm going to cover off the introduction and then hand over to Adam. Then I'm going to come back a little bit later to cover off some of the bits nearer the end of the paper. Um, I'm guessing most of you, if you haven't read the whole paper, at least you've read the abstracts that gives us an idea of, overall what to expect from this. Well, let me just review that first, just to kind of orient us in what we're going to study here. So they're going to introduce this benchmark called MLE-bench, and it's a benchmark designed to measure how well AI agents perform at machine learning engineering. Well, they're going to need to define what they mean by machine learning engineering, and they do next. So they've worked from Kaggle. So they've taken a bunch of competitions from Kaggle, things that people have already solved, challenges that have been around for maybe a couple of years. Some of them are a bit newer, but they've taken these challenges and they've set up an agent and asked how well can that agent do at solving those challenges independently. That word independently is a little bit loaded, and we'll come back to that when we talk about this question of contamination and plagiarism. But the idea is, can an agent solve these challenges? And if so, how well? And how do we measure that? And that's what the benchmark is about. They mentioned that they are using OpenAI's, well, they're using a bunch of different models and a bunch of different what they call scaffoldings. There'll be a bit more detail on that shortly. But they mentioned that OpenAI's O1 model with this thing called Aid, that's just a agent framework, that gives the best performance overall. And they look at, certain questions around the validity of these results as well. Contamination, for instance, they cover. So let's have a quick look at the introduction and just pull out the pertinent points from this. Um, Kind of, the background to why they're doing this is what they start with, and they mention that language models in general have achieved increasingly impressive results, and performance with coding benchmarks. So we know that modern language models can write code for us, they can complete code for us, they can analyze code and find bugs or refactor it and things like that. And they're good enough that these things tend to be now integrated into our programming tools, right? We have things like GitHub Copilot that we can just use on a day-to-day basis. So we know these work well, but the context in which they are used typically is one where it's kind of a copilot helping you write code. What it's not doing is saying, here is a programming challenge that requires a complex set of requirements, but also in this case, it requires machine learning models to be trained, it requires data to be analyzed, it requires the model to be evaluated. So it requires all of these different things, these different disciplines and skills, in order to complete the task. And the existing models haven't been evaluated in that context. So that's what they say here, right? That while there's been this surge in capabilities, there aren't benchmarks that measure how well a autonomous agent can perform that end-to-end machine learning engineering. And that's why they're introducing their MLE bench. So they describe it as an offline Kaggle competition environment. What they really mean by that is it's an environment that kind of just lives on its own. It, it contains, you can offer descriptions of problems to the agent and have it try to solve them, and you can measure how well it's done at solving them. And these are problems where existing good results are known, right? So human beings have tried to solve these and um, got good results from them. They talk about how many, like the spread of different domains that these competitions cover. So natural language processing, vision, signal processing, and they mention some of the specific ones. Open vaccine is one of them. I hadn't come across this before. It doesn't particularly matter actually what these are. For me, they're just examples of what they're using to evaluate the models. But the final thing they mention is, you know, the prize value. Effectively, supposing that these were unsolved challenges, then this is how much money could be won by someone with a successful agent solving them, right? Just, food for thought there. Not sure what that means for the future of Kaggle. In any case, um, final thing there then is this point, which is that their claim that successful AI agents, i.e., agents that can solve these Kaggle challenges, could accelerate scientific progress. Now, it's an interesting claim, right? For me, being able to solve completely new to science problems is very different to being able to solve a well-described Kaggle challenge. So I'm not entirely convinced of that leap of logic there, but you know, I can kind of see where they're going with it at least. That if you have an agent that can do machine learning engineering generally, and you've got a way to evaluate how good it is at that, then you could throw at it unsolved big science problems and see what happens. I'll just finish with this 4-point summary of what their contributions are before handing over. They are contributing MLE-bench. We've mentioned that. That is the benchmark of 75 Kaggle competitions. They have a bunch of evaluations off the back of that of current state-of-the-art models and different agent frameworks. They use the term scaffolding kind of interchangeably with framework. It's important to note. And experiments on scaling the resources for these agents, different scenarios, what happens in those scenarios. And finally, they talk about, plagiarism, cheating, effectively whether there's a risk that these agents aren't really solving the problem they're presented with, but they've just learnt, they've seen solutions in their training data already, so they're just reproducing those.